Okay, example one, ignore the bottom one for right now. Example one, sodium plus chlorine produces sodium chloride. So we have Na and we have Cl2 producing NaCl. So normally when I go to balanced chemical reaction equations, I do everything except hydrogen and oxygen. I leave hydrogen and oxygen for the end. Why? Well, when we look at more complex reaction equations, oftentimes hydrogen and oxygen can show up in several different compounds in both the reactants and the products. So it makes it hard to start with those. Oftentimes, if you start with the other elements in the reaction equation, the hydrogens and oxygens will kind of sort themselves out by the end. This one, however, we don't have any hydrogens or oxygens. So we kind of just have to pick one. Doesn't really matter. So I'm going to work from left to right. So right now I have one sodium in my reactant and I have one sodium in my product. Are those balanced? Are they equal? Yeah, 1 equals 1. Okay, so let's move across. Let's look at my chlorines. I have 2 chlorines in my reactants and 1 chlorine in my product. Are those balanced? No, they're not. So I have 2 here, I have 1 here, so I'm going to add a 2 in front because this 2 distributes to everything inside that reaction equation. Now I cannot add my 2 down here. That totally changes the chemical formula, so I can't do that. Remember, the only thing you're allowed to do are to change the coefficients. So now I have 2 chlorines and I have 2 chlorines, but what else did that change? Change the sodiums as well. So now I have 2 sodiums on my products. I only have 1 on my reactants. So that's a pretty easy fix. I just add a 2 right there. So just to fill in the blanks, remember you don't have to include the ones. I'm going to go ahead and put a 1 here. So if we were writing this without filling in the blanks, we would write this as 2 sodiums reacts with chlorine gas to produce 2 sodium chlorides. And that's what that would look like when it's balanced. That one was pretty easy. Let's try one that's a little bit harder. So we have C4H10 reacting with oxygen gas, producing carbon dioxide and water. So this is a really good example for waiting to do the oxygens and the hydrogens, because while hydrogen only shows up in one thing in the reactants and one thing in the products, oxygen gets split. So we're going to start with other things first. So we have 3 elements. So my plan of attack is I'm going to do carbon, then I'm going to do hydrogen, and then I'm going to do my oxygens last. So let's do carbons first. I have 4 over here because I have C4. Over here, the only place of my carbon is in my CO2, and I have 1. So 4 does not equal 1. So I'm going to add a 4 in front over here. Okay, so now I'm going to look at my hydrogens. So I have 10 hydrogens in the reactants. I have 2 hydrogens in the products. 10 does not equal 2. However, if I put a 10 here, now how many hydrogens do I have in my products? I have 20. It's not really what I wanted. I only wanted 10. So I'm not going to put a 10 there. I'm going to put a 5. And I'm going to put that 5 because that 5 distributes. So 5 times 2 gets me 10. So you see how I did that? 5 times 2 gets me the 10 that I need. So you're not always going to put the number in front that you, the total number that you need. You got to take into account the subscripts. Okay, so we did carbons and we did hydrogens. That was pretty straightforward. Let's check my oxygens. Well, I have 2 over here. Let's add them up over here. I have 4 times 2. That gets me 8. I have 5 times 1. That gets me 5. 8 plus 5 gets me a total of 13 oxygens on that side. Okay, fair enough. Over here, if I put 13 in this blank, 13 times 2 gets me 26. That's not what I wanted. I wanted half of that. I wanted 13. Well, over here when we did that, we just cut this number in half. Can I cut 13 in half? No, that would get me a decimal. Do you think you can have decimals as coefficients? Well, it would make life a lot easier if we could, but actually we can't. Coefficients have to be whole numbers. So that's yet one more rule of balancing chemical reaction equations. You cannot have decimals or fractions. They have to be whole numbers. So I'm going to show you a little trick. If you end up in a spot where you can't come up with a whole number to fill this, here's a trick. Try doubling everything. So I'm going to make this a 2. I'm still going to leave this blank because we haven't figured out what number that's going to be yet. Instead of a 4, I'm going to turn this into an 8. And instead of a 5, I'm going to turn that into a 10. Okay, before I move on, let's just go double check our numbers. Let's check carbon. 2 times 4, that gets me 8. 8 times 1 gets me 8 carbons, so those are still good. 2 times 10 gets me 20. 10 times 2 gets me 20. So my hydrogens are still good. Okay, so now let's check our oxygens. Let's do this again. So 8 times 2 gets me 16. 10 times 1 gets me 10. 16 plus 10 gets me 26 oxygens. 26 divided by 2 gets me 13 oxygens, or 13 O2s, which gets me 26 total oxygen atoms. So if you ever get stuck and you can't come up with a coefficient that's not a fraction or a decimal, try doubling everything. See if that works. Oftentimes, that will solve the problem. Now, kind of the last thing about coefficients is that they need to be in the lowest ratios possible. So if you can go through and divide all of your coefficients by 2, divide all of your coefficients by 2. They need to be as reduced as possible. Kind of like fractions, you want to reduce them as much as you can. So if I look at this one, these numbers are kind of high. So let's just check and make sure. That I can divide by 2, that I can divide, my 8 I can divide by 2, my 10 I can divide by 2, my 13 I can't. So believe it or not, even though these are fairly high coefficients, this is actually the balanced chemical reaction equation. So be patient, take your time. Remember, they need to be whole numbers. You need to have the same number of each type of element on your reactants and your products. And when you're looking at a more complex equation, start with elements other than hydrogen and oxygen, then do hydrogen and save oxygen for the end.